Okay, so I think it's part 3 of making a compiler. Let's go to the project. And where we left off in the previous video was in this assembly front-end thing, where I will continue with today. So I realized that I also need some sort of temporary buffers to buffer output to. I think, unless there's a better way to do it. But basically, our code will have different. The assembly code will have different sections, and we need to make sure that all of the generated output gets placed into the correct sections, basically. And I'm not really sure how I'm going to do this. 'Cause I don't like to buffer output like that. Let's see. So actually, maybe I can do that stuff here. So basically, so if the assignment thing we're encountering here is the main function, then we're actually going to generate the start code for or the start label in the assembly version. So maybe in the assignment we should check, is this the main? And if it is, then we're generating the start label. So maybe we should, I don't know. So we're going to, let's just start with that and see where we go. So basically, if string compare AST name, is that really doing that? Parse assign, no, assign. So your name will be the value token equals, and value is, yeah, that's correct. So if you are main, I don't really like doing string compares like this, but we'll see if we can make it prettier later. So if you're the main method, then we're going to generate the start flag. So const char template is equal to dot global start and something like that, I guess. Assignment. Maybe we should even add a comment here. I don't know. Expecting. Expected expression. And then we're going to return s. Okay. So like if I run that, we're getting that. Okay, cool. Cool. And then like whatever is inside of this, like whatever the so this assignment has a value assigned to it, of course. If we go in here, we can see that the value is an expression, and we're actually going to encounter this list expression here. So, and since this is the main method, it's going to have some it's not going to do the same things as other methods might do. So really, we don't really care about that argument list for the main method. We'll expose those arguments either way, but so what we can do is so basically we have the AST assignment value, which is equal to AST value, and this assignment value also has a value actually, and some children, and the children is a list of AST nodes, but it's the value here that we're actually interested in. So what we're going to do is sharp as val is equal to ASF value. Okay, and then we're going to do S is equal to realloc strlen S strlen S plus strlen val plus 1 times size of sharp, and then we're going to string cat yes. We're going to put this into there. Oh, too many welds. No. Oh. So obviously we're not getting anything from there, because now we're actually encountering a compound here, and that compound has a call. So I think we're actually going to encounter this call here if I'm right. Yeah, so we're actually encountering this call. I wonder why we get a sig fault now all of a sudden. I don't know. But anyway, so we're encountering a call here, and this doesn't really return anything at the moment. So so when we're, I decided to, instead of having statements like return statement, it's actually a function call. I don't know. It makes the front end it makes it confusing here in the front end. So I'm thinking maybe I should have statements after all. I don't know. Call. Because otherwise we have to like do some kind of comparison here again. So like if string compare AST name, if you are a return, then we're actually this is also depending on if we're in the main method or not, because if you're in a function in assembly, then return actually means something else, kind of. Unless we always treat, what if we always treat, actually I have an idea. So what if we always treat this the same? So if we don't do this, let's scrap that. Okay, and then we're going to do, I'm just gonna have some coffee. So we're going to do this instead. We're always going to treat this the same. But this is that's only if the value is a function definition. So basically we only want to do that. We're still gonna have that if here. So if AST value type is equal to AST, don't we have the AST list? AST compound. Oh right, we're doing a compound, aren't we? I think we're doing a compound. Parse list. So the parse list is actually a compound, which is cool. So in the front end here, if you're an AST compound, we should probably also do if AST value, just to well, we're always going to have a value there actually, but anyway, so if the type is a compound, then we're going to assume that it's a function definition. So if you're a compound, then we're going to do global and the name. And what is your name? Well, let's add some more Sterling AST name, and we have to do ×2 because we're using the name twice. Okay. So then we're copying in this, but we want to do sprintf now instead. So we're going to do sprintf s with the template, and we're going to put in the AST name. value is equal to that. Okay, so if we do that, and then we're doing that. Okay, Sigvault. So T compound 61 value is equal to realloc next value. Oh, is it because you're returning 0? Okay. Yeah, but we need to do a realloc here instead, so so why are we never ending up here, or what? Sprintfs template. It's okay. Why are we not ending up in there? So we're reaching an assignment. Parse assign. Maybe you're actually a function. Because parse ID, parse. So if we're parsing a if we're parsing an ID and we have an equals, then we're parsing an expression, and we're going to encounter the it's going to go into parsing a list, but then it actually does so. If we encounter an arrow right, then we change the type to a function. So actually, this is actually a function. Cool. So now we're getting that stuff. And now in the return, when we call here, so now we can actually treat this as a call. So call. So if we call return, if we call return, okay, so let's just do this. So if string compare AST name return, then then we're going to let's do this thing again. So if we're encountering a return, we want to first we want to move what it is we're returning into a register. So if we want to grab the first argument here, so ASTT first arg is equal to AST children size. Then we want AST children items 0. Otherwise, we're just going to should do a 0. Why are you angry? No, that should be possible. Items. Okay. So let's just see if we're getting something here. So let's print the pointer of this sigvault. Okay, sigvault. So the return. Why aren't you having any children? St. So est children. So why don't you have any children? Or do you have children? So instead of that, let's print. So turn S, and we're going to print the est children. Are you allocated? No, you're actually nil. So why are you nil? That's pretty weird. That's pretty weird. So when we parse the list and we make it into a function call, so we're creating a compound. And then we're pushing some arguments into that compound. But why are you not? So if we do this here, printf you have children in there, so why are you angry with me? You should have some children. So we're doing what if I print you in here? So you have children? You have children? Oh, wait. Oh, wait. So, actually, we're encountering a ID. And here we're doing, oh, okay, I see what the problem is. So actually, it's in the value, so are we getting you now? Yeah. Yeah, we're getting an address, so that's really good. And I think this is going to be an integer. So if we do first arg type is equal to est int. Yes, it's an integer, so that's awesome. So now what we want to do is const char template is equal to move something like that, and then we want to do cast chart. Ref s is equal to character template, and we're gonna add some extra bytes here. Size of sure. String cat. No. Printf ref s template. First arg int value. First arg, and we're going to default to 0. Okay, and then we want to do this type of thing, and we want to do well, that's not what I what the that's not what I wanted. Why are you doing that? I have escaped. I have escaped it. So why are you doing like that? Do I have to like do that or something? No. What? Well, let's just do this then. Is it possible to just like is it possible to write in that somehow? I think we can probably do this, right? No. No. Okay, let's open up browser then and see enter Oh, so I can just do like that, I guess. Maybe. No, that didn't work. Why? Oh, so you put two of them? Yeah, that's what you do. Okay, cool. So we got that going. Awesome. So now obviously, you know, this is not going to run. So let's do this. We're going to have a, I think we're going to have a default start thing where we will just call our main method basically. So const char section text is equal to and we will basically do call main, okay, and then we're going to do what? We're going to move one into EX. No, actually move EX into EBX. And then we're going to move one into EX. And then we're going to, and then we're going to call int. I might be all wrong here actually. We'll see. So are you even? You don't really like that, do you? We'll see. Okay. So what are we doing here? We're defining the section of text. We're defining the start method. We're calling main, and then we're moving the EX into EBX, and then we're calling the exit. I think that makes sense. We'll see if it works. Okay, and then we want a we want to reallocate value. So value is equal to realloc value Sterling section text, and we might as well add. We don't really need to add some. We don't really need to add any bytes. We're just going to add 1 byte, and then we're going to do times size of sure. And we're going to do a strcat section text. Okay, so what will you give me? Invalid size. Okay, realloc. So sure value is equal to realloc value Sterling section text size of. Okay, let's just see where you are failing. 88. What's your problem? What if I don't do this? Then it works. Oh, we seem to. Oh, wait. Obviously, we're gonna get this multiple times because this function is being called multiple times. So actually, we only want to do this the first time. We only want to do this the first time. So maybe this shouldn't be here, actually. Maybe this shouldn't be here. So what I think we could just create another method here called char isf root or something like that. And we will do this. Still gonna need you here though. And we're going to do char value is equal to, we don't need you. And we're gonna do a calc. And then we're going to just simply do char next value is equal to asf ast, and we're going to do a this type of thing. And we're going to do string cat value next value return value. So Makes sense. And now what you have to do is go into where we're calling this. So where are we calling this? I think we're calling it in here. Yes, so we're going to do ASF root instead. Root. And we also have to copy this signature and put it in here. Stop it. There we go. Kidding me. So we're getting some weird shit happening here. Looks better. Looks better. Let's add some more new lines here, actually. So we have this, we're calling main. What, now we're getting double quotes. Or double percentages. Okay, that's better. I'm actually not even sure this will run, but maybe we can try. So if we do that, and we do ASTest.s and test.o and ld test.o test. So that's actually returning 0. Cool. Okay, so what if we remove this test and we generate a new one, but instead of returning 0, we want to return 2. Will you do what I want you to do? And then we're doing a AS test.s test.o ld test.o test, and we're getting a 2. Cool. So that actually works now. That's kind of cool. So right now we have a dependency on the assembler and the linker. But as I've said before, my ambition is to actually have my own assembler later, but we'll see about that, okay? But for now, I actually think that I would like to actually, or maybe we'll do that in the next video. I was thinking about like sort of putting the assembler and the linker inside of our compiler, and it will automatically assemble it for us and generate the file. That would have been kind of cool. but maybe we'll do that in the next video. Maybe we'll do that in the next video. Or should we do it now? I don't know. Maybe it's not that difficult to just do it now. So we're going to have a write file as well. So tag write file shard buffer. And we're going to do that, and we're going to sort of do. It's not going to return a shard then, but let's just do void for now. And we're going to do a write, I think like that. And then we need to call write. We need to call write. So we're going to do write. So we want to write to the FP, and we want to write the out buffer and the size of out buffer, I guess. I think that's how you do it. I don't know. Is that all? I don't know. So you're returning something, so okay. to do this. Right, five pointer. So I guess we could just use fprintf. Fprintf. Okay, so let's do that. So where's fprintf? Fprintf. So let's see if we can do this. So wow, that's weird. Why did it get such a weird name? Actually, I think I know what's happening here. So in the, I'm actually having a new line here. So now we have the a.s file here. Doesn't look good at all. Oh, I think it's trying to format it. So the fprintf is trying to format it. Crap. So what if we use this instead? So that doesn't really help, so I actually think this is better because I don't think fwrite is going to, try and format it, so and we want to write the out buffer. So out buffer 0, 0 divided by sorry, size of out buffer 1 by XP. No. What's wrong here? Oh, let's just use outputs then. There we go. Okay, so the next thing I wanted to do was to invoke a syscall. So if we go to, I think we have this in another project of mine. So if we go in here and we look at, could be IO maybe, no, could actually be here. Yeah, here it is. So let's copy this thing, and we're going to put it in think that's all right. And then we can do AS S and we can do so how about that? So a examples main.tag error invalid character. Oh, we got some weird shit in here. We got some weird shit in here, so what's wrong with you? So this was move to EX, which is actually happening here. Oh, because I still have this thing. Look at that, it generated the a.out file. So if we do that, and we remove the test, remove test.s. So now I can basically compile this file here. So if I run make, so we have our, actually let's do it like this. So here is basically our compiler, and if we run a.out on examples main.tag, you can see that now it actually it actually wrote over the original a.out, but now that a.out file is actually what this thing was compiled to. Maybe I should rename our compiler to tag.out. So now if we remove a.s and stuff like that. So now let's just recompile. So we're going to do make. Now we have our tag compiler here, and if we run that on examples main.tag, that generates this a.out file here, which is this tag program here. So now if let's say we return 16 and we recompile that, and echo, we're getting 16. So that's pretty cool. We're able to compile this main function here. So yeah, I think that's going to be it for this video, and thank you so much for watching, and I'll see you in the next one.